Hi everyone, this is lesson 2-1. We'll be discussing power and radical functions. Our learning target for today will be for students to be able to graph and analyze power functions. To analyze what a power function is, we first need to know what a power function is. And a power function is any function in the form of f of x equals a times x to the nth power, where a and n, both the values of a and n, so the coefficient and the exponent, are non-zero constant real numbers, meaning they have to be just a number with no variable attached to it, and it cannot equal 0. That's what non-zero means. So a and n, both the values of a and n, cannot be 0, and they can be any constant real number. A power function is also a type of what we call a monomial function. The prefix mono means 1. And so if we're looking at a monomial function, any function that can be written as f of x equals a or f of x equals a times x to the nth power, where a and n are non-zero constant real numbers. So you could have f of x or y equal to some number, or you could have f of x equal to a times x to the n. So there's two different forms of our power function. You could have, I'll give you an example here, you could have just like f of x equals 3, or you could have f of x equals 2x to the second, would be an example of ax to the nth power, where both a and n are non-zero constant real numbers. Now that we're talking about power functions, we can look at the different types of monomial functions. If we're looking at the different types of monomial functions that can occur, we could have several different situations or several different types of graphs. And the graph is going to be different based on the values of n and the values of a. Okay, if n is even, so if our exponent or power is even and our coefficient is positive, then our end behavior is going to be up in both directions. Okay, so think about a being positive, and if the power is even, your end behaviors are going to be both pointed up. Now, if n is even, so if the power is even but the coefficient is negative, so I'm just going to give you an example here, y equals negative 2x squared. Okay, then if your coefficient's negative but yet your exponent's even, then both ends are going to be pointed down. So an example of this graph over here, and where n is even and a is positive, could have been positive 2x squared. Now we know from the previous unit, if I compare these two functions, that putting a negative out in front of the 2 reflects that graph over the x-axis. So really these two, this function here and this function here that I've been discussing, okay, 2x squared and negative 2x squared, those two graphs are just reflections of each other over the x-axis. Okay, in the boxes here, they talk about analyzing the function. All of these things we've talked about before, talking about the domain of the function, the x and y intercept, the continuity, its symmetry, it's whether it's decreasing or increasing, what its extrema are, so it shows that it has an absolute minimum. We have an absolute minimum at 0, 0, and our end behavior, specifically when we're talking about the ends being pointed straight up, obviously our end behavior here would approach infinity in both directions, and over here you're going to approach negative infinity in both directions because both ends are pointed downward. If you have a monomial function where n is odd and a is positive, so now we're looking at an odd function, which is an odd exponent function. So we're going to have a is positive, our coefficient's positive, so we'll say something like 2x to the third power. Okay, because our exponent is odd here, and our coefficient is even, when we have an odd power, that means our end behaviors are going to go in opposite directions, meaning one is going to be pointed up and one is going to be pointed down. If your coefficient's positive, then your right end behavior is pointed up, and when your coefficient is negative, so for instance negative 2x to the third power, then since our coefficient's negative, that means our right end behavior is going to be pointed down. And our left one would be pointed up because our power here is odd, which means our ends cannot be pointed in the same direction. So up here, when the power is even, that's telling you that your ends are pointed in the same direction. When our power is even, but yet our coefficient's negative, our ends are pointed downward. If our power is odd, so 3, 5, 7 are all odd numbers, you know that the ends of your graph are going to be pointed in opposite directions. So now the way we determine which end is pointed down and which end is pointed up is by the coefficient. If the coefficient is positive, the right end, as we go towards infinity, is going to be pointed up, and as we go towards negative infinity, or the left end, is going to be pointed down. Here, since our power is odd and our coefficient's negative, that means our right end is pointed down and our left end is pointed up. So here, as we approach positive infinity, as x approaches positive infinity, right here, our end behavior is going to approach negative infinity. And on the left side, as we approach negative infinity, our end is going to be pointed towards positive infinity. Now, all of these functions here analyze the domain, range, x-intercept. I'm not gonna review that with you because we've talked about that for the last 10 or 11 weeks. You guys should be able to graph the function and analyze the domain and the intercepts and the continuity and such. In example 1, we're going to analyze monomial functions. We are going to graph and analyze f of x equals 1/2 x to the 6th, describe the domain, range, intercepts, and behavior continuity, and where the function is increasing or decreasing. Now, in order to determine what this graph is going to look like, I need to look at the coefficient and the exponent. Now, the exponent is equal to 6, and since 6 is even, I know that both of my ends should be either pointed up or both pointed down. Both my end behaviors have to be pointed in the same direction anytime my exponent is even. Now, to determine whether they should both be pointed up or pointed down, I look at the coefficient. Since my coefficient is a positive 1/2, anytime our coefficient is positive and our exponent's even, our end behaviors are both going to be pointed up. Now, if this function had a coefficient of negative 1/2, then both of my end behaviors would have been pointed down. So what I'm going to do on the next slide is I'm going to go ahead and confirm that both my end behaviors are pointed up by graphing the function, and then I'm going to analyze my function by describing the domain, range, intercepts, end behavior, continuity, and where the function is increasing or decreasing. So after graphing the equation, y equals 1/2 x to the 6th, I've confirmed that my end behavior is pointed up in both directions like I thought it would be. Now what I'm going to do is analyze the domain, the range, the y-intercepts. So my domain, since the function is continuous from left to right, x is not under square root or in the denominator of a fraction, I know my domain is negative infinity to infinity. My range, however, because my minimum is at 0, 0 here, I have a minimum at 0, 0, so my range is going to go from 0 to infinity. My x-intercept is at x equals 0. My y-intercept is at y equals 0. Again, I could find the x and y-intercept by the x-intercept by plugging in 0 for y and plugging in 0 for x for the y-intercept. And I would say the continuity is continuous. The function is continuous. There's no breaks in our graph. The function is continuous from negative infinity to infinity. Our end behavior is going to be the limit as x approaches infinity of the function is equal to infinity, and the limit as x approaches negative infinity of the function equals infinity, because both ends are pointed up. The intervals of increasing and decreasing, I would say the function is decreasing. The y values are decreasing from negative infinity to 0 until I reach that minimum. And then it increases from 0 to positive infinity. Under the check for understanding, you need to describe where the graph of the function f of x equals 2x to the fourth is increasing or decreasing. You have 4 choices, A, B, C, and D. I would like you to go ahead and analyze the function and determine whether the function is where the function is increasing and decreasing, and submit your answer.